two arguments and then print out something where again the evaluation of the first argument is substituted into the string, followed by the evaluation of the second argument. So now we've got something a little bit more interesting, because each time that yields passes control to the block, it passes control with values of two arguments. So we actually get slightly different behavior each time. Trivial in this example, but when we come to using Rails, we'll see this is an incredibly powerful technique for refactoring your code, because what we can now do with the use of yield statements is to succinctly factor out repeated chunks of code, not as functions but as blocks in their own right. It's used quite a lot as a way of implementing iterators, and this is another nice easy technique to do something. So in this particular example we've got a string of words which are animals, and then we've got that same structure of a method being invoked on animals each, and that method is a method which is declared for arrays, and it has a yield statement in it. What it's going to do is pass each object that's in that array successively to the block that is the parameter there. So each animal is in turn going to be passed to that block. Animal will get instantiated and will print out the animal itself. So when we do that iterator, it's just going to, as so often a very simple example, it's just going to print out in turn the name of each animal. But if we've got a complex array, we can use iterators to very succinctly step through and perform the same operation on each element in that iterator with a very simple statement. Just a very quick bit on writing. We've used puts, which is an unformatted print to the command line. If we want to format, as you would expect, there are formatted print statements, and here's an example one, and nothing really unexpected about that. If you're a Java or a C programmer, you'll be quite familiar with the sorts of way in which that's structured. So although for simplicity I've used puts, if you want to format a print statement, then this is straightforward and of course is supported. So those are the very basics of the syntax of Ruby. Let's now just introduce quickly classes and objects within Ruby. As I said before, I'm using the examples from the Pickaxe book so that you can see this explored in a little bit more detail if you wish to. So do refer to that book for exploring this a little bit more, and do try out these examples. They're very, very simple. The structure of classes differs quite in small ways but very significant ways from the structure of classes in Java and C++. As with so many things, the purpose behind that is just to simplify and clarify what one's doing within an object-oriented structure. So we use a very simple bookshop example, and we're going to record some information about books, the date, the ISBN number, and the price of the book. And we're going to place all that and write all that information into a file. So there are a number of things that we might want to do, which is, for example, to look into that array and find out how many copies of a particular book we have, what's the total value of the books in the stock, and so forth. So we're going to use some simple operations on sets of objects within a class and so forth. Very, very simple. So the first thing to do is to either use NetBeans or work at the command line or use Eclipse, whatever is your favorite, to set up a simple project called Bookshop. And we'll create a first class which we'll call Book in Stock. So instances of this may well have the same ISBN, but they will have some other unique identifier. We'll talk a little bit about that later. So skeleton class, as before, no curly braces. We'll use N to delimit the end of the class definition, and we're going to create one method, first method in there, an important one, which is initialize. As with everything else, no curly braces. The beginning and end of a method declaration are identified by the def and the end keywords. So we have a method initialize declared now, and we're going to do something very simple, which is just to initialize an instance of a book with an ISBN number and a price. So there's a little bit of difference here emerging, not just the use of def-n and avoidance of curly braces, but we've got an @ sign appearing here. That's to make a very clear difference between something which is a local variable, which is an undecorated name, and something which is an instance variable which is prepended with the @ sign. So it's, in a sense, as with other language, mere coincidence, but a design feature, but a useful convention to follow, that a particular local variable has the same name as an instance variable. It's just to make it very clear that @ISBN refers to the instance variable. Undecorated ISBN refers to a local variable. We're going to use the local variable to pass a value to the value of an instance variable. In this particular case, what we're also doing is casting price into a float before assigning it to the respective instance variable. So the assumption here is that price has been received from a form as a string. Hopefully someone will have done a little bit of used a regular expression to check that that string will cast correctly into a float, but the actual casting of it into a float is done in that initialize. So it's checking that the variables are of the right type, the values of the right type, and assigning it to instance variables. What we can also do is to print out some objects now. We can create new 3 new books. They happen to have different ISBN numbers, but we can create 3 distinct books which have the same ISBN number, of course, but they will have unique identifiers in the background, something again we'll come back to a little bit later. We can use a very simple print statement to print out the values of the instance variables, but normally you'll want to do something a little bit more elaborate, and as with Java, there is a toString method which can be overridden to customize the way in which you print out the state of an object. So all objects in Ruby have a to_s for toString method, and you can then override that with your own particular definition. In this particular case, we're going to add a little bit of syntactic gloss around the values of the 2 instance variables, as you see there, and print out something which is a little bit nicer. I don't give you the output. That's for you to test on your own at a Ruby console. but you can guess what's going to happen there. You should be able to guess what's going to happen there. In each of those cases, it will print out capital letters ISBN, followed by the evaluation of the ISBN instance variable with a comma, then price, and then that's followed by an evaluation of the instance variable price and terminates. So some very simple stuff there, just to kick off the introduction to classes in Ruby. In the next lecture we'll go into the use of classes in a bit more detail. But the key thing to remember there is a very simple syntax for the declaration of classes. We've got something which looks a little bit different to other object-oriented languages because we've got an initialization, not a creation method in there, and I'll say a little bit more about the distinctions there next week. And we've seen a little bit about how to customize the printing out of state of an object. All of the features I've shown are distinguishing features of Ruby, and they make programming in Ruby a little bit more simple, a little bit more declarative than other languages. And they are all features which are used extensively in Rails, and it's one of the things which has enabled Rails to be very powerful and very succinct as a framework.